Hello world and welcome to this video. In this short video I'm going to be showing you how to create your own trading bot using Node and this API that we have right here, Alpaca. So this API allows you to get market data, real-time market data, and make trades which link to your broker account through Alpaca. So a couple disclaimers. First of all, anything that you make, I'm not responsible for. Any money you win, lose, gamble, or just throw out the window, I'm not responsible for. This is for entertainment purposes only. We will only be using paper money, which is one of the great things Alpaca does for you, is allows you to paper trade, which is nice, so you can kind of get some practice and train your bot and see what works best for you. Now, another disclaimer, what I'm about to show you is not completely finished. There's definitely a whole lot of testing to do, and there's even some functionality to be filled in, but there's enough logic in there that I figured it would be good to show you, and you would be able to see how it works and how you can do it yourself, how you can put your own trading strategies within your bot. And so it's at that point where, any more work I put into it is going to be for my own personal use. And we don't want every bot to be the same, otherwise they kind of stop working. So this bot is going to be for me, but I want to show you how I made it and how you can create your own as well. All right, so first thing to know is we are going to be trying to train this bot to trade this pattern, this bullish engulfing pattern. And the reason why I chose this is because it's a very simple pattern to recognize, and it only requires 2 candles to look at any given point. So obviously you want to find a downtrend stock, and then you're going to be looking at the last 2 candles. So like, let's say it's whatever this time is here, we're going to be looking at these 2, so that when it does get to it'll get to this candlestick, and we'll be looking at these last 2, and we'll be able to see, oh, this last one was a bearish or a bullish engulfing one. So then we know we should take the trade right here, and then we'll set a stop loss down here so that if it does go down below, we won't lose everything. But we'll set a limit to a 2-to-1 ratio, meaning that if we put our trade here, and we have our stop here, we want to put our limit order, or we cash out our profit goal to be 2 times the difference here. So that's kind of what I have set up for you, set up so far. So let's get into some of the code. Now, Alpaca does have a Node SDK, which allows you just to use their API kind of directly, like functional. However, I did find some issues with it. It wasn't able to, for some reason, the start and end parameter weren't working for me, so you couldn't specify which market data you wanted to get correctly. So I ended up just using their REST API, which works fine. But yeah, let's take a look into the code. So quickly, the only external library I'm using is this dotenv library, which allows you to pull variables from this .env file, which is where my API information is. I've changed it, so obviously this is not real, but this is what the file looks like, just these values are changed. So if you want to get your own API key in secret, you can sign up for free at Alpaca. I am not related to them, I'm not affiliated, but once you sign in, you get this, and you go to the paper trading section. You start off with 100,000 equity, and you can generate your API keys here, and then you plug in those in your .env file right here. The only other library I'm using is Node fetch, and that's because in Node there is no built-in fetch method yet, so we have to use a library called Node fetch because I like the fetch method. Okay, so you'll see we have a couple of library functions. So what I've tried to do is try to kind of put a lot of the try to keep the business logic in this index file, and then doing things that connect to the API in these separate library files. So technically, if we were to switch libraries, we would be able to just switch out the library files but keep the business logic the same. That's all in theory. Of course, things would have to get changed up a little bit. But anyway, so this is all this is a basic Node. This is not Express. There's no framework. All basic Node stuff. The only thing we're using is Node fetch and this .env dependencies. So you would start your folder with npm init, set it up, and then you just create an index file, get the .env and node fetch. And so you'll see we have this init function, and the reason why we don't just call this and out of the init function is because we want some of this to be async and await. And in order to use await, it has to be within an async function, which is why it is in this init function, because this init can be asynchronous. Okay, so I've kind of commented out the steps. So the first thing you want to do is we want to recognize the bullish engulfing pattern. So first we have to find a downtrending stock. Now, I haven't gotten to this part yet, but again, this isn't the part that I'm too concerned about at the moment, because you can manually do this on your own and then set it. So right now it's just awaiting. It's a promise based, and it goes into this get downtrending stock, which you can see comes from my library function, get downtrending stock. Currently it's just returning a static value. So this is a stock PM that we want to use. So now obviously you could put your own logic in here that would detect some downtrending stocks, and Alpaca does have some APIs to help you do that, and it's probably something I will do in the future, but for now I'm going to leave it for manual, just so I can get this thing up and running. So we got our symbol, right? And now we want to check every minute the last two interval candles before the current minute. For example, if the time is 9:32, we want to check the bars at 9:30 and 9:31. Like I said before when we were looking at this here, so in this example, once we're at this bar, we want to check the last 2 minutes. And so that's what this check and order function does. So first what it does, this is how many milliseconds are in 1 minute, 60,000. So we get the now date, the time, and this gets the current date. And then so the start, remember, it's going to be 2 minutes before the now. So if it's now, we want to go 1 minute, 2 minutes, because we're trading on 1 minute intervals here. And then the end date is, so that's why we say now minus 2 times 1 minute, and then we go to the ISO string. The reason we do ISO string is because that's what the Alpaca API expects. The end date is just going to be 1 minute apart. So the start date is going to be 2 minutes from now. The end date is going to be 1 minute from now. So we're checking these two bars right here. And then we're just going to log out. We're checking the bars, and then you can see I was running it just a minute ago. And you can see this is what it logs out. Just so you know that something's happening. I don't like to run a continuous function without anything logging out because just like, is it working? I don't know. You don't know what it's doing. That's why I try to log something out. And so you'll see it's doing it a bunch, because in a minute we're going to run this on an interval. But first we have to define the function. So after we get the intervals we want to check, then we get the bars at those time periods. So I have this function called get bars, and we pass in the symbol and the start and the end date. So the get bars comes from this get bars library function, and this is the actual Alpaca API. So I have it in a try catch in case anything goes wrong. It just logs it out. But obviously you could put in some better error handling in here. So we see all we're doing is we're fetching using node fetch. This is the Alpaca API for the bars, the market data. And so you just pass in the symbol, the start, and the end, just like this. And you pass in these headers in order to authenticate with your, this is why we use the .env library, so we can pull these API keys in secret out of our .env file. Okay, so once we get that initial data, then we have to return it into JSON. And now typically you'll see await response.json and then return that data. However, if you just return the response.json like this, it returns a promise. Hence, in our index file, we are awaiting it, because this is essentially waiting for the JSON to resolve. So this bars would be the JSON response from this API. Okay, so now that we have the bars data, and so this will essentially give us 2 bars. It will give us bar 1, which, as we said here, is 2 minutes before now, and it'll give us bar 2, which is 1 minute before now. And so what this is saying, so the API, let me actually just log this out so you can see what it looks like. We'll just do console log bars, save it, and then we're just going to do node index. Okay, so as you can see right now, it is Sunday, so the market's closed. So there are no bar values, right? But let's try to put in some fake dates so we can see what the data actually looks like. So if we go to, we'll just go directly, how can we do this? We want to kind of spoof some dates. So I'm going to go find, actually there might be a way to do this. Let's check. A lot of times what I do is I just go to any Chrome window and I just kind of mess with the new date or the date API to find the date I want. And I've actually been using this a lot lately. So what is an actual date? So let's just check Friday. So this would be 8/14. Okay. So if we do 8/08/14/2020 at, let's say, remember stock market is open from by default mine's in Pacific Standard Time, so it's 6:30 a.m. So we'll just do 7 o'clock a.m. See if this works. Yeah, so this is a correct date, it looks like. So then we just do to ISO string. Okay, cool. So now what we're going to actually do is we're going to test this out with this date instead of the now. So if we go to index and we do, if we actually pass this in, so by default it does the current date, but if you pass in a string like this, it should work on this date. And so all of these are all relative to whatever the now is, because we're doing now and then minus. So this should work. This should give us some data. Let's see. There we go. So so at 7 a.m., remember we're checking the last 2 minutes. So bar 1 is going to be here, the first one, and then bar 2 is going to be here. So we see we have all these variables. You can look at these in the API for Alpaca, but essentially this is what the O is what it opened at, the C is what it closed at, the L is the low, the H is the high, the V is the volume, and the T is the timestamp. And so if you look from this bar to this bar, look, it opened at 7,895, and then the next interval was 7,7,855, so 95 to 55. So this actually went down. So this is technically, well, this is open. So what did it close at though? 7, yeah. So it looks like it's in the down trending direction. Obviously, you would want more data to confirm that, but this is the data that you would get back from this get bars function. Okay, so I'm going to stop this from running. So I'm going to undo that, but that is what the bars data would look like. Now, this is the logic that we have that I have, and this might be not completely right. There might be some tweaking that needs to be done, but this is the part where if you have your own trading strategy, this is where you would implement that logic. So first thing I want to do is, because this can get very confusing very quickly, I want to write it in pseudocode. So this is the rules that I want to follow to check for. So first, and this helps if we have a bar kind of to look at to see what this logic is doing. All right. So remember, we're gonna consider the happy path, and we're gonna see what would happen. We wanna, if we're checking this bar, this time frame, we're really checking these two bars. So this is bar 1, this is bar 2. Now let's see, does bar 1 and bar 2 exist? That basically means is there data in bar 1 and bar 2. Remember when we first started, there was no bar 1 and bar 2 because there's no current data. So this is basically saying, is it open? Is there data flowing at this time? Does bar 1 and bar 2 exist? Okay, if it does, then we want to see, does bar 2, so I did write the pseudo logic up here, and then I did include this extra one. But so the first one, does bar 1 close before bar 1 opened, or is it closing less than bar 1 open? So if bar 1 closed at a lower value than when it opened, that means it went down, which is what this red candle is right here. So that's why we say if bar 1 close is less than bar 1 open, then it passes. Goes to the next one. Next one, if bar 2 closes after bar 2 opens, which means if bar 2 closes, sorry, I keep saying after and before, bar 2 closes greater than what it opened, that means it's a green candlestick. That means it's a bullish candlestick. It's going upwards. So if you pass these two, that means the first candle is heading down and the second candle is heading up. That's a good sign. Now we're going to check if the bar 2 closed greater than bar 1 opened. So if bar 2 closes, which is this one right here, after bar 1 opened, so opened is going to be here, that means that it is engulfing from the top. So then we're going to see if bar 2 opened right here less than what it closed at, which is down here, then we know that this is a bullish engulfing candle. And then lastly, we want to check if the volume is higher, because if the volume is not higher, that means that there's it's kind of weird to even see this candle if the volume is not higher. But essentially, we want to confirm that there were more people trading on this second candle than there were on the first candle, because that means it's about to spike up, supposedly, in theory. So we're checking the volume from bar 2 and making sure it's bigger than the volume from bar 1. So you can see in this example, it's not. The volume, there's more people trading on the first bar than there were on the second bar, which means basically it's starting to go down. But in this case, like the bar size would be going down. If there's a high volume, the bar is going to be more volatile. And in this example, in the screenshot here, we want the volume to be really high in comparison to the first bar. I hope that makes sense. So if it passes all of this logic, then essentially we want to make a trade. So first thing we want to do is we want to determine how much we want to spend on this trade. So just by like a rule of thumb, we're going to get 10% of our current account value. So again, this is an API that's not filled out, but something you could easily do. So I have this get account value, and Alpaca has an API to get your current account value. So right now I'm just returning a static number, 5,000. So in my head, you call this API and it's going to return a value, let's say 5,000. So that's how much you have in your account right now. We want to trade 10%, so we're going to multiply it by 10%, which is this 0.1. So that's how much we're willing to spend. Now we want to find out how many shares can you buy with 10% of that account value. So first, what you have to do is find out what the current price of the stock you're trying to trade is at, and then basically divide it into how much you're willing to spend, and that's how many stocks you want to trade. So for example, if you had $1,000 that you are willing to spend and the stock price was $100 each, then you would be willing to spend $10. Now we want to round that down, so we're using math.floor because there's probably going to be a decimal point, and we want the amount to be a solid number. We don't want to float. So that's why we're using this math.floor. So if the amount you want to spend was 1,000 and the cost of it was 1,001, you couldn't buy 9 shares. You couldn't buy 10 shares. You have to buy 9 shares. So that's hopefully what this math.floor is trying to do. And if you look, we're actually dividing it by the second bar closing price. So this isn't technically accurate to what the current price is. This is what the closing price is 1 minute ago. So if you're in this area right here, we're looking right here. So technically you should look at the current value price, which there's probably a better API to find the current. But the thing is that the current price is constantly changing, and by the time you get the response back from the current price, it's going to be slightly off, because by the time you get the price and then execute it, you're going to be slightly off. So this number is not going to be 100% accurate, which means you may spend a little bit more than you want to, or a little bit less than you want to. But the goal is to hopefully keep it around 10%. There might be a 5% discrepancy at the most. So just keep that in mind. The amount is kind of depending on the market, how fast it changes, and if it goes up or down. So anyway, we find out how many shares we can buy. Now we want to buy this stock. So we're just going to call this function buy market. Now again, this part is not filled out. In fact, so all of my buy, sell, stop, sell limit, they all are in this orders file. I want to actually open it. Here we go. So I have a buy, market, sell, stop, sell limit. Now, if you know things about stocks, you know you can buy at market, you can buy at limit, or you can sell at the limit, or you can sell at the stop, make a stop order. Advanced traders would only be selling and buying limits in stocks. However, for this purpose, I'm going to be doing a market order. just because just starting it out, and might end up changing us to limit. If we can kind of determine a price that we want the limit order to be executed at, then we would be using a limit. But for now, we just kind of want to get in where it's at. That's why I'm using a buy market. Now again, all of these APIs are not filled in, but in my head, we would hit the API and we would return the actual value that your response gave you. So if you bought in the buy market order, it would return this object with the price you actually bought in and probably some more, some other data. But we need that price. We need that purchase price. So you buy the market, and you take the purchase price, and now we want to set the stop at the bar 1 closing price, which is right here. And actually, this is a mistake. See, we should not be setting the limit here at the bar 1 closing. We should be setting the limit at the bar 1 low. So let's change this to bar 1 low price. Instead of the C variable, we're going to use the L variable. Simple fix. So we're going to sell the stop, and again, this is another function, and we're going to pass in the symbol, what price we want it to sell at, and in this case, we want to set the stop at the limit of the first bar, which is here. And then we want to say how many we want to sell. In this case, we're doing all of them. So the same amount we purchase, our stop order is going to be the same amount. That way, if you buy 100, you're going to set your stop at 100. And now we're going to set our limit order, and this is for our profit ratio. So when do we want to sell the stock and actually make some money? So the goal is a 2-to-1 profit ratio, which is kind of the golden ratio what most people strive to get. Obviously, this would be potentially leaving a lot of money on the table if this spikes up more than 2-to-1. Now, this is definitely where there's room for improvement in this logic. So sometimes people will take a 50% limit order at a 1.5 profit ratio and then let it ride out and then just kind of keep putting stop orders as they go. I didn't want to overcomplicate that logic for now, but we may have to in the future when we want to optimize this. But I did kind of put the logic and wording here for what we're doing. So for now, we're going to be setting 100% limit order at 2-to-1 profit ratio. So that comes out to, you take the purchase price, you minus the stop price. So remember, our purchase price is right here. And we minus the stop price, which is what we sold it right here. In this case, it's bar1.L, which we need to update it here as well. So you minus the stop price, you take that value, and you times it by 2. So what that is if you purchased it here and you sold it here, we want to take the difference and multiply it by 2. And then we want to add it onto our current purchase price. And that would create a 2-to-1 profit ratio. Now, the thing about a 2-to-1 profit ratio is, the good thing about it is that you only have to be right 33% of the time in order to break even, which means if your bot is right 50% of the time, you're making money. So that's kind of the goal here. So obviously, there's probably a lot more logic that needs to be put into this, but that is when we would set our limit order. So that in theory, every trade we make, we're either losing, let's just say $100, or we're gaining $200. And we're kind of trying to keep that ratio every time. And if we can add more logic into this flow to make it so that the percent is right more and more, which means we would add more indicators in here. Maybe we want to check if there's, we can get some other chart indicators like the moving average and see, and only make the trade when the moving averages cross or something like that. Then that would increase the percent that this is right, which means we would profit more often. And if we always keep this profit ratio, then as long as we're over 33%, we will break even on the trades. Now, of course, there's going to be some fees. So you don't want to break even, because then you'll end up losing money. So you do want to, I aim to get this bot to be trading at 50% correctly, which would be great. So and that's basically the whole function. So we're going to run it once, and then we're going to set this in an interval. So basically we're running this every minute. So 60 times 1000 milliseconds is every minute. So we run it instantly, and 1 minute passes, we're going to run it again, and then keep running it over and over. So that's pretty much it. I hope you enjoyed this video. I hope you take this and do great things with it. Put in extra logic, put in the work, put in all these other functions that need to be filled in, and you could potentially have a successful trading bot. Obviously, I'm not responsible for your gains or losses. The logic is completely up to you. This is just kind of a starting framework to create your own trading bot with Node.js. I actually had a lot of fun making this so far, and I actually can't wait to get this working and completed. And maybe I'll do a follow-up video to how my bot actually did. But anyways, I'll put this code up in a GitHub repo so you can just pull this, and hopefully you'll understand it now and be able to tweak it to whatever your heart desires. So thanks for watching this video. Make sure to like, subscribe if you're not already, and I'll see you next time. Bye-bye.